Hey everybody, welcome to this week's development update. I wanted to start doing these weekly so that we could start having more engagement. Progress has been, I guess, a lot more visible because a lot of the foundation work has now been essentially completed. So to recap a little bit, what some of you have talked about this before. I essentially built a framework in a framework. So I spent a lot of time over the last number of years really thinking about the future of the API, how it will be to develop just new API functionality, and seeing a bunch of the code that repeated itself, essentially figuring out how to template that and create an API framework. So that also makes it, if you are developing your own custom APIs, you have that framework to develop on. So I'm going to recap a little bit about what's been done over this past week, what's in the core, and then what to expect, and kind of give you guys our Tritium++ rollout plan. I'm going to refrain from giving specific timelines at this current time because bugs can happen, things can change, but everything's been moving forward pretty steadily. So even little details like the contract DSL, which DSL, if you guys recall, stands for Domain Specific Language. That is done. It's an output mode, I guess, more than an input mode. So if you're one of the people that's actually testing the new mobile wallet, you'll see some of that coming to life. If you look at some of your transactions history, you'll see conditions at the end of it, and that shows you the actual virtual machine contract language. That's essentially equivalent to our Solidity, but we don't directly expose that in the API so that developers don't have all the cumbersome burden of really developing secured smart contracts, because it's not only difficult to do that, but we don't know what we don't know. And a lot of security firms nowadays are still playing catch up on figuring out exactly how to perform an effective smart contract audit. So if you guys remember back in the days of one of the notorious Bitcoin smart contracts, or not Bitcoin, sorry, Ethereum, it was called the DAO. And there was a company called Slock.it, and they were supposedly the company that had performed the security analysis on the code, passed it off, said it was good. Then what happened? Well, $60 million got drained out of a $100 million fund. And that's actually the beginning of, Fork Ethereum, where essentially their claim to fame was code is law. But what ended up happening was code was not law, because code law was, what Vitalik said. Essentially what they did is they censored their contract. They essentially overrode it, made an exception to the chaining, and said that this contract now is a withdrawal contract and not a DAO contract. And they did that to save all of their immediate investments in that smart contract, because a hacker managed to penetrate and crack it. So that was the genesis of Ethereum, essentially. As far as I observed, for any of you that aren't familiar, I've been developing blockchain or involved in the industry since about 2013. And I started developing Nexus in about May of 2014. So this was predating Ethereum. So I watched Ethereum come, the ICO. I watched it at 25 cents. Then we watched the DAO. And what noticed happened is after the DAO, that's when the Enterprise Ethereum Blockchain Alliance was formed by JP Morgan Chase and Microsoft. And all these large companies started to endorse it because they proved to themselves that the code is law principle was folly to developer centralization, right? They essentially censored the contract, changed it to a withdrawal contract, and thus that split Ethereum into Ethereum Classic and Ethereum, where the Ethereum Classic was the people, the miners that believed in the original ethos of Ethereum. And so they did not censor the DAO contract, and the people that The main Ethereum chain got a withdrawal contract so they could withdraw their funds out of the broken contract. So that's the genesis, right? That's where it all began. That's when Ethereum really started to make prominent waves, right? But the reason I went on this discussion here is Slock.it was the one that performed the security analysis. And there's just not a very well-known security analysis tool yet for smart contracts. So there's not even a really utilized smart contracts very much either. They're very basic. You have DeFi, which is essentially I'm staking a coin for a coin, which is, you could say there's negligible benefit to the world. So the conditional virtual machine I built without exposing it directly in the API. That's our smart contract functionality. That virtual machine has been tested. A simple operation like multiplication is, I think, about 50 million cycles per second, operations per second, which is about 50 megahertz. So it's very, very, very fast. And our virtual machine is a register-based virtual machine where Ethereum and all of the other, even the Java virtual machine, are what's called a stack-based virtual machine. And just to prove some of the merit of that, some people redeveloped the Java virtual machine using registers rather than a stack. And I think they got 30-40% speed up because you just have less operations that you have to send to the CPU. So register-based virtual machine. The conditional VM is driven essentially by bytecode, and there's standard contracts. So when you send your coins, if you've noticed, if you send it to an invalid address or it's not claimed by the recipient, then the coins come back to you. That's because of that smart contract. It's the default contract. It's an expiring contract. So we've gone with the method of developing sound logic in contracts that are very simple. It's Boolean logic, so that people can essentially drag and drop these contracts as a web builder. So that allows people that develop on tools such as Bubble to develop without actually having to touch code. And you can even, get to complex smart contracts with just simple API requests. So that was really cool to be able to see the contract code. So you'll see that in your transaction history. If you're using the newest mobile wallet, if you're on the private beta, you'll see conditions at the end. That's the conditional virtual machine. That's the DSL, the domain specific language. Now it's an output language, not input. On later iterations, we'll make it so you can actually code the code into bytecode, and it'll compile and all that. So let's go through what's been done. So last week we left off. I was talking about the crypto API and the remote login API and the peer-to-peer messenger API. So last we had left off, I had developed a Kyber handshake class that essentially allows the exchanging of public keys to create a shared key between the two of you in order to engage in an asymmetric encryption channel. So that's using full post-quantum cryptography. Now, it's implemented, it's running. I got it implemented in the relay server. The relay server is the RTR, as I was talking about, that architectural component. That's reverse tunneling router. That's a Lisp terminology. Lisp standing for Locator Identifier Separation Protocol. That is Dino Farinacci's work. And any of you that have studied the architecture of the Nexus protocol from NPWP, which is the repository name, it would be github.com/nexusoft/np-wp. That's the architectural document. It's driven by the one stack, which stands for Open Nexus Execution Stack. And that essentially it utilizes the Locator Identifier Separation Protocol, where your locators and your identifiers are separate, which means think of it like having a phone number on the internet that doesn't change. If I go from my Wi-Fi to my LTE or the coffee shop down the street, I'm going to have a different identifier each place. Now imagine if you had a single common identifier no matter where you roamed, which would make you always accessible. And if you guys recall last development update, I talked about NAT, Traversal Network Address Translators. That's a big hurdle to peer-to-peer. And not just in traversing a NAT, but also if you have a peer that you want to connect to, but they're at the coffee shop today and not at home, you're not going to be able to form that direct connection like you would um, without. So that type of locator identifier separation protocol helps in bridging that. And so on the way towards the deployment of LXOS and the Nexus protocol, you're going to be seeing locator identifier separation protocol semantics in it. So there's some very basic forms of that in it right now, where you bind your Genesis ID to a specific location, which would happen to be your IP address, and it's authenticated. And so I've essentially been able to deterministically generate a security certificate, essentially using lattice-based cryptography. It's Kyber, which is the winner of the NIST post-quantum competition. We're going to support Kyber and Saber, which are very similar in implementation. And then obviously we have Falcon for digital signatures. So it's fully authenticated, which means you not only do the key exchange, but then you hash the public keys, which are always deterministically the same. And then you verify that to the certificate value in your crypto object register. So your crypto object register essentially becomes your certificate authority. If anybody doesn't know what that is, you have to go, if you want to do HTTPS, you have to purchase that certificate from a certificate authority, Symantec or Komodo or any other big ones. And essentially what they're doing is they're signing the certificate with one of their signing keys. And their signing keys are verified in a public key database. So when you get that security certificate from that website, you're not only getting the public key in order to do the key exchange mechanism, but you're also getting a signature signed by that certificate authority to verify that they verified that public key to some sort of entity. And that way you know that it hasn't changed. Because if you did not have that security, cryptography doesn't really mean anything in identifying people. I've heard some people say cryptography is intended to identify people. It depends on how you use it. In the general sense, if you're opening up a secure socket layer or a transport layer security connection, you don't have any identification qualities just from the public keys, because a public key is just any arbitrary number, and the public key essentially is used to encrypt and the private key to decrypt. So you have a mathematical relationship between those two, but that's it, right? You don't have any identification unless you tie that to something. So generally that's bridged through public key databases. You keep a database full of public keys, you tie that to some known identity, so that identity being a domain name. So when you go to that domain name, you get the security certificate, you check that it was signed by a certificate authority that has a public key entry of that tying to that domain name, which basically means that somebody can't man them that'll attack you. They can't go and create their own self-signed security certificate and try to decrypt traffic and then re-encrypt it to your endpoint. That's the whole point of certificate authorities, but they're centralized. And the reason being is because the internet has architectural deficiencies that haven't been resolved. They've been resolved in a centralized way, I should say, but the internet was designed to be more an open, decentralized system. Anybody that's been to the IETF, Internet Engineering Task Force, it's a bunch of loosely built working groups, which our DAO social architecture is loosely developed from, is studying those social architectures and how they developed that, along with other methods. But so the Kyber handshake class, it hashes that public key into your crypto object register, which ties to a specific Genesis identifier, which means that you know for a fact that there's nobody doing a malicious attack because you are attempting to connect to this specific username or Genesis ID. And you, by hashing that public key, you know for sure that somebody isn't in between you and the endpoint that you think you're talking to and decrypting all the traffic while sending you their public key, right? Because then you'd hash their public key and you'd see that it doesn't match the crypto object register of your recipient. So you therefore make certificate authorities completely obsolete. So in this relay server post-quantum encryption system, there's no need for certificate authorities. So you essentially have a type of HTTPS between nodes without the need for purchasing security certificates. They don't have to expire. The way that the deterministic key generation works is it generates a different private key but the same public key. So you get a different shared key each time. So you get a lot of randomness in that way. And you essentially create a session key. And then that's the first layer. Then the second layer of the handshake is providing an actual authenticated message, which is signing, okay, this is the timestamp, this is who I am, this is when, how long this session is valid for, and so on and so forth. And you want to put those timestamps in there to protect against what's called a replay attack, where if somebody's listening, they grab that packet and they replay it to someone else pretending to be them, and you have a valid signature. But if you don't have some randomness, entropy, or timestamps in there, then they can use that 1 month from now to authenticate themselves, right? And that's a replay attack. So it solves all those things. It works. It's piped into the relay server. I just have a couple more protocol commands for the relay server, and it's going to be ready to fire up and start essentially making remote login requests. So the reason 5.2 kind of wrapped everything together, or it got all kind of wrapped together just with the addition of the remote login, is this relay server is what was needed for the peer-to-peer messaging to work correctly. The Kyber handshake was what was needed for the peer-to-peer messaging to work. And then all of these cryptographic primitives now being put in place, that was the final pieces that were missing for the crypto API. So it all kind of tied itself together in the development of just that one single feature. So that is all looking very good. Development's continuing steadily. By next week, we'll most likely be able to start doing some demos and tests, potentially before then. I'm wrapping up, I have wrapped up a lot of the mobile wallet code. So Kendall and me have been working pretty hard the last couple days. We've gotten a couple private builds out. I think we have one bug that's been reported, and it only happened to 2 people. So we're investigating that bug. Other than that, we've had fairly good reception with it. Synchronization is much faster. We're working on optimizing the battery life. Kendall right now is working on some new builds for Android and iOS that we will be publishing today. We're going to open the beta with the new 5.1 core, which this is multiple years worth of work in the core. If anybody's used the prior betas, that was using the old 5.1 core. So this is all the work, the fruits of all of this labor of these many years. So it's actually only really been about almost 2 now, since I started refactoring it. About 120,000 lines in to refactor it, but not just refactoring the client mode, but just redesigning the entire authentication system, the indexing system. I mean, lots of things. I mean, there's some requests, like, invoices list invoices could take up to 45 seconds just on a remote node to process, and now it's sub-second, right? So in some cases, 30, 40, 50 times faster. And when you start dealing with disk bottlenecks, every cycle you can save really means a lot. And that also means less cycles on your mobile wallet. So be prepared for the new mobile wallet release. I will post the links on the recording. So this is the live right now. On the next tweet I will do with the recording recap, I will start essentially with that. So let me see. Let me make sure it is recording. Perfect. Okay. Just wanted to make sure before we got too deep. Should automatically do so. But anyway, so that recording, we will post the 2 links. There will be an Android link and an iOS link. If you're on Apple and your iPhone, make sure to download Test Flight. That's going to be the app that you're going to need. Android, I think you can just do an APK. It downloads directly in. There's one known bug that happens when you start up. If you get a weird transaction history, like you see a weird unconfirmed, like semi-grayed out transaction at the top, make sure you report that and give me your log files, because I'm tracking that down. But you have to replicate it, and it hasn't happened on my device. Well, it happened at first, I think, with that specific one, and I got it working, but I want to develop either the fix to it for one, and 2, the way to resolve it if it does happen, so that your node can essentially continue to function. It's more of a cosmetic thing than a functional thing, but that's pretty much the only report that we've seen. And then other people have reported they want battery life optimization. So we're going to get into the optimization cycles next. This one, we just want to make sure the code that's there is solid. So that's a mobile wallet. We're shipping out a live public beta today. So that's ready to go. As far as what we've done so far, there's might be another 1 or 2 beta cycles. it could move pretty quickly depending on how good you guys report. So make sure you look in the core logs folder. You're going to see inside, you press the gear and then you scroll down and you're going to see core logs. That's what we need. Okay, so I need that file. If you get any strange bugs that happen, I need that file. That's really important for me. So I found a few other bugs from the releases over the last couple of days, so it should be pretty stable now. We've got all the relay nodes set up with it, so that's essentially. Just got off the phone with Kendall. He's also helped me set up a build environment for iPhone on my Mac so that I can start developing directly into the iPhone, because I want to improve some of the background refresh. If you've used the iPhone version of it, you basically have to re-log in. Once you close it, once you go on the lock screen, you lose sync. So there's background refresh, but Apple makes you do a bunch of reach arounds to get anything done. So it's not quite as straightforward as Android. So I'm going to be diving into a lot of that over these next couple beta cycles on that to get our background refresh really up to par. And then that'll allow us to process notifications and then send those notifications to your lock screen, such as, new transactions come in, they need a credit, and so on and so forth. And ideally, it should stay in sync in the background without having to have it open, and it should synchronize in the background as well. Sync time, I think it was about 2 minutes, maybe 3 minutes. Not on this version. Well, this version is about 2 or 3 minutes for me with a pretty reasonable connection, but just over LTE, not any Wi-Fi or anything, not any really fast internet. But I'm going to improve that probably by a factor of 2. By the final version, I can reduce the chain size. I got it from 800 megabytes to 400 megabytes in the data chain. So that's also going to reduce your bandwidth requirement, and that's going to make it sync a lot faster on your local device. I potentially am going to port the new lower level database, Bloom hash map, into the mobile wallet for the final release. This one still has the old lower level database that was launched with Tritium. I would like to have the Bloom hash map version because it's a little bit better on disk space. It's more efficient. It's going to take less write cycles, and it's less critical. It's the LOD, for those that don't know, is a very critical component. If there's a bug in the LOD, the network could fork. If anybody recalls Bitcoin, when they had a fork, I think it was 2011, 2012, it was from the database, right? Just because it didn't have enough locks to write, and it failed on a write, and then when you fail a write, then that block fails, and when that block fails, then you go off mining your own. So the database is very critical. So I want to stage that Bloom hash map in, phase that in. That's been done for quite a long time. It's just not been thoroughly, well, it has been thoroughly tested, but just to my standards, I burned out about 3 or 4 solid state drives in the testing. So you can say it's very thoroughly tested, but I don't want to run critical network infrastructure with it just yet. So the mobile wallet's a good place to kind of kick that off and integrate that in. And like I said, it'll save on disk space, and that's also going to save your battery life a lot because you're going to have less accesses to the disk. You're going to have less cycles that are going to be required, and it'll overall make it sync faster and load faster and all that stuff. So that's the mobile wallet. Since I'm developing the remote login system, this is something I spoke with Kendall and Christo about. We're discussing, as I get more into the iPhone side of things, and I get the remote login API built, I want to have that integrated, or have a basic interface integrated into the mobile wallet. And then Christo, I just talked to him about integrating that in the desktop wallet as well. We should be seeing a desktop wallet public beta released in the near future as well. Not as soon as the live beta for the mobile. That I have one more bug as far as when you log out, it crashes if you're staking. So that's the only bug I really have to fix on that, and then we're good to go with the new desktop wallet. So you'll be seeing the new desktop wallet following sometime in the near future, most likely by the next development update. So that will be, we'll do one last live beta for the desktop wallet, and then the desktop wallet's going to be pretty much ready to pack and ship. Christo said he's doing a few more UI adjustments, and that's going to be the first phase of Tritium++. So I wanted to discuss what our rollout plan is. This has been a lot of infrastructure to develop. There's a lot of infrastructure for hybrid networks that have been running use cases already for the past year. There's also, the client mode mobile wallet infrastructure that's taken a lot of extra tending to get it correct. And then there's your regular desktop wallet infrastructure. So all of these things are going to be released in a series of 3 steps. We're going to have the first phase, which is going to be the new desktop wallet. That will be version 5.1. It will be all of the new UI work, multiple years worth of work from Kendall and Christo, and all of the new LLD core. It will be much faster, all of the things. So that's going to be our first phase. And so you'll expect that. We're obviously in public beta phase right now. When we get to release phase, that's going to be the first thing that you're going to see released, is the desktop wallet. Then the phase 2 is going to be another desktop wallet, but it's going to contain all of the final features of the crypto API and the peer-to-peer messenger API. And depending on time, there's might be some bells and whistles built on top of that. So we're going to have the remote login, at very least, being able to input your PIN and select, that you accept a certain login request. Ideally on both the desktop wallet and the mobile wallet, but currently we're planning on just the mobile wallet, but there very well could end up materializing in the desktop wallet as well. So that's kind of like a 2-factor authentication, as I've described it before. Think of it like the YouTube app. So when you go to log into your Google account, if you've had the YouTube app, it says go to your YouTube app and select that you accept, and you go in and do that, and boom, you have it. This is much more secure than 2-factor authentication that has a code that sends you a text or anything like that, because a 6-digit code is not too hard to brute force. This is using public key cryptography underneath the hood, and it's requiring that in order to proceed with the remote login. And so we felt it was really important to have at least some basic remote login functionality in the mobile wallet so that people can start developing web apps with the remote login, which could very well just start as simply as running a node to replace OAuth, for instance, which is a Google authenticating system. I believe OAuth, last I checked, was about $1 per user. So, I mean, just the incentive of the cost reduction is going to be a massive drive for people. The second area is that you don't have to manage credentials anymore, and you don't have to expose yourself. You'll feel much safer. You don't have to type your credentials in any web service. You just essentially type it on your phone, and then when you type in your username to log into the web service or sign up, it's going to send a request to your mobile wallet that will ask you if you want to accept that. You can accept or deny it, and then any blockchain-related transactions that it wants to invoke, such as creating an asset or any of the you will have to accept and put in your PIN number for. So you'll know everything that's being accessed. Think of it kind of like when you link your Facebook or when you link your Google, it asks for permissions for certain parts of it. Think of it like that. That's how it's going to feel. As those of you that have seen our design structure is really around reducing the barrier of entry. So we want to make things feel as consistent with what we've already been using as possible. So log in with Nexus. It'll feel like the other login systems, just like when you use the mobile wallet, it feels like you're using your online bank. So phase 1, desktop wallet. We're essentially in phase 0 right now, which is public live beta of the mobile wallet. Like I said, Kendall's working on the builds right now. We should have links for that a little bit later today. I'll post them on this recording so that you can get involved in the public beta. Then the desktop wallet, full release, in the desktop beta as well. And then that really comes down to this me wrapping up this last bug. And then we get to the first release, which will be the desktop wallet release. And then that's phase 1. Then phase 2 will be the desktop wallet release with the final 5.1.5.2 features packaged into there. Maybe a few UI components, depending on the time. Christo may be able to add remote login functionality into the desktop wallet. And then the hard fork with the difficulty adjustment, as we were discussing prior. That will essentially be just improving the difficulty fluctuations. There's some calculations that use reserves and stuff like that that was really designed back when the hash channel was launched. It was a month behind because it launched a month after the network launched. And so it needed to catch up on, like, I think 2 million Nexus. So I needed to develop some things into the difficulty adjustment to reduce the target time when the reserve was high, so that it could deplete that reserve to get the hash channel supply equalized with the prime channel supply. So that's going to be changing. So that hard fork with the phase 2 desktop wallet release will be a mandatory update. This first desktop wallet release will not be mandatory. The phase 2 will be mandatory, Tritium++ phase 2. That will be, and it will activate 3 weeks, 2-3 weeks, maybe a month, depending. Bittrex usually likes to have a little bit extra time. So we'll set that time when it's released. You'll know that. Anybody that's been here before, you know how it works, where you have time lock activations. And then we get to phase 3, which will be the App Store mobile wallet. So during this phase 1, phase 2, phase 0, we're going to be testing and developing the mobile wallet, making sure it's solid. Once we feel it is at an adequate point, then we will submit it to be accepted by the Google Play Store and the Apple App Store. And that will be the completion of phase 3, which will include the remote login built into that mobile wallet. So that could very well be parallel to phase 2, as far as, the desktop wallet with the hard fork could be timed very succinctly with the mobile wallet. We may have extra time. We may develop some other fun features along the way. There's no real saying exactly what's going to materialize, other than those specifics that I gave you. That's what to expect. And desktop wallet first, then desktop wallet hard fork for Tritium++ phase 2, and then mobile wallet in the App Store and the Play Store, right? And now the hard forked version will, like I said, include the 5.1, 5.2, and that's also for the application developers to have access to the peer-to-peer messenger API, the crypto API, and the remote login system, so that people can start developing that. That also, as I've stated before, offloads computation for you onto local devices, so it helps in scalability, especially for people developing on Bubble, because Bubble only allows you to make one API endpoint, so you can't create a whole cluster like you normally could. So this will help with the scaling of your web apps, security, and it's going to set a new precedence, I believe, for how login systems are managed. There's already keyless or passwordless login systems starting to come out, where people are using public key cryptography to actually make the sign-in, which is a step in the right direction, but you still have the key management issue. So this solves all of those things and gives you that two-factor authentication in your mobile wallet or your desktop wallet, if that's what you choose. So then that's phase 1, phase 2, phase 3, right? That's the rollout for this Tritium++ framework that we've been developing for the last number of years. Then off from there, we're going to move into some of the highly demanded features. And that will include the Ledger virtual machine, which essentially will be like a conditional virtual machine, but on the Ledger layer for managing cryptographic primitives. So that will allow you to create access patterns in your SIG chain. So you'll be able to say this set of credentials, and think of an access pattern as a set of credentials. So you have this set of credentials that has this access to your SIG chain, which could be, I want to create a staking account, a staking set of credentials. And now on the actual cryptographic layer, not in your wallet, where like right now, you can set it to unlock for staking only, but that's only protected in your wallet. This will be protected on the actual blockchain. So you essentially can say, I only want this set of credentials to be able to stake. And that's it. No unstaking coins, only create trust transactions. And so that way, if those credentials get compromised by someone, you don't have that pitfall where you have to worry about if they're going to steal your coins, right? Because they won't have that capability. And you obviously have a master set of credentials that allows you to change any of those sub credentials and your recovery phrase, which is essentially, that is your recovery phrase. So access patterns are really important. Now, this also adds different elements to your recovery, right? You could say, I want these 5 words to be in access with an and to these 5 words. And obviously those will be hashes so that you can distribute, or you can add someone's account. So think of it as basically being able to do true false logic to create access for your account. So you can have joint accounts a lot safer that way. You can have husband and wife, and your wife can have access to debit to a certain degree, or it requires both of you to sign, and then that's when you're going to get ledger level two-factor authentication, which that will essentially require two actual signatures to generate a transaction. The remote login two-factor authentication is you're requiring a PIN number and your node to be online and for you to act in order to perform some action on a web app. The ledger level two-factor authentication is essentially having two sets of credentials, okay? And one of those sets would be your username PIN essentially, and the other set would be username password. And then you have to combine both of those. You have to generate two separate signatures in order for that transaction to be processed. So that way you can break up your credentials. You can do the two-factor authentication as a device if you want. Make that as a separate potted device so that you can plug that in to generate that specific signature, kind of like how you have that in your bank. You have that number that changes on your bank to access in your bank. You could do things like that. There's lots of possibilities, and there's not going to be any limit to the and or logic, right? And so then we'll also allow you to create access patterns for the future, such as I'm going to create the set of credentials that I'm going to give to my children, let's say, that if my SIG chain is inactive for 2 years or 5 years, which means there's been no transactions generated, then that activates that set of credentials, which would essentially be you die, right? So you'll be able to create these additional access patterns for the future, such as I want to have kind of a crypto will, right? That's how a crypto will would work, is this ledger level virtual machine. So that's a really important component. And it creates all these different security properties. It removes the security from just needing a PIN to maintain staking. And most people will probably have a staking set of credentials, probably have their master set of credentials, and then probably a multi-sig pattern. That's going to most likely be the very basic type of access patterns. So that's a ledger level virtual machine. Then from there, pooled staking. Pooled staking is essentially your ability to join with other people in a decentralized way to stake. And you can combine together your hashing power. You'll be able to combine it to reach a higher staking power without having to have all the monetary resources of so many single individuals. So what that'll do is kind of vires and numeris, right? Power in numbers. It allows people with a bunch of small tokens like 1, 2, 5, 10 Nexus, which really you have to have about 10, 20, 30,000 Nexus to really maintain a good trust account. This will allow people together to join and stake, but it also is a really cool architecture because as you add more people together in a stake pool, which it's going to be stochastic, which means it's going to be randomly selected. It's not going to be that like you join a pool where somebody operates. There's not going to be any pool operator. It's just people on the network discover each other and combine their work together, and they do a stake round. And it provides you a really high degree of security, but also availability. And that's what's really beautiful about it. Generally speaking, in order to increase security, you reduce availability. Think of Bitcoin mining, okay? The higher the difficulty goes, the less available it is for you to mine, but the more secure it becomes, right? So generally, higher security, less availability. This will create higher availability for people to stake, but higher security at the same time, because all of these people staking in the stake pool are going to actually have to agree on the same set of transactions rather than it being just one individual. So in order to manipulate that, it'll be much more difficult because you have all these other people that have to agree with you. Currently, as long as you have the highest weight in the chain and you get the block first, then your transaction history is what becomes the blockchain. This you'll have, let's say 100 people joining together in this stake pool. They will have to all agree on the same set of transaction history in order for that to proceed forward, right? So the staking pool is really an important architecture. It's been a really highly demanded feature. So that's coming on the Tritium, post Tritium plus, right? So that, ledger level virtual machine. Then we have pooled staking, and then augmented contracts. That's another really important one. That essentially extends our conditional virtual machine into essentially a full-fledged programming language. Right now, it's a register-based virtual machine, but we've limited the functionality deliberately because we wanted to make sure we got our T's crossed and our I's dotted. We wanted to make sure we had all these things correct before proceeding to adding complexity, because as you add complexity, it becomes more difficult to debug, more difficult to optimize, and there's more things that can go wrong. And since these technology is so new, and there's not even really a standardized model for even how to perform a security audit and consider that an effective security audit, we've scaled it in slowly. We've wanted to do that in a way that we don't add too much too fast and end up with Ethereum and the DAO, right? As a lot of us know, the scalability of Ethereum is negligible. The security is very difficult to maintain. If anybody saw, for instance, Gavin Wood was the principal designer and coder of Ethereum. He's doing Polygon now. I believe they had a big code library on one of his projects. I forget what it was called. And he forgot just one line of code, which this is how it happens, just one line of code. He forgot it, that designated him as the contract owner. So somebody was able to just suicide that contract, to send a call out to say, hey, this contract's now dead. And that contract essentially was a dependent for all these other contracts that locked, I think, $200 or $300 million worth of coins in. So when that contract became suicided, just like John McAfee, right? Yeah, he was suicided, man. But once that contract was terminated, I should say, but it's technically the opcode, suicide, I believe. Then all of these other contracts were now unspendable, which locked up, I think, a few $100 million. Big mistake. Very easy to make, right? One line of code, he forgot. So we like to prevent those types of things from happening. We don't want to have those types of stories on Nexus. So we take things methodically, we take them slowly. In our logic, we're building financial systems that could last the next few hundred years, 1,000 if we do a really good job. So a few years now to save hundreds of millions of dollars in the future, definitely worth the time for me. And that's just our logic. So you have the ledger level virtual machine, then you have the pooled staking, and the augmented contracts. All three of these require a hard fork again. So we're going to have our Tritium++ hard fork that's going to be coming up in the near future. And then after that, we're going to be doing another hard fork with these features. Now, the final hard fork, which could be combined with those other three features, will be the DAO voting protocol, the core level voting protocol. So I want to take a moment to explain that architecture to you guys now so you can understand how that's going to work. So for those of you that are staking, you know that you have an amount of stake and you have an amount of trust, right? Your trust determines what your reward is for staking. So think of your trust and your stake as like a single value. Think of it, just multiply them together, or however we derive that value. Think of them as a single value, coin-weighted trust, okay? Now, think of it like a stack of poker chips that you set on the table. Now, the more trust and the more stake you have, the bigger that stack of poker chips. Now, everyone else on that table has their own stack of poker chips. The more stake, the more trust, the taller their stack. Now, when a proposal comes out for an embassy, which essentially is a decentralized governance body, and it's there to cope with the developmental centralization issue, which Ethereum is funded by the Ethereum Foundation, and I think Vitalik is the sole leader of that, the sole director. So really, the Ethereum development is managed by just a small number of individuals. We want our development to continue to flourish and grow, to have more individuals. Right now, I believe there's Kendall, Christo, Andrew, and me are the principal developers. We come to consensus. Nobody's in charge. We talk to each other. Kendall calls me out. I call Kendall out. Crystal calls Kendall out. Kendall calls Crystal out. We all have a really nice mutual feedback, And Andrew, he's phenomenal, by the way. If anybody, I just want to give props to Andrew Hatstat. He developed the Prime miner, and he really he managed to decentralize the Prime channel. So he's done a lot of really incredible work. So if you see him, El Jefe, make sure you give him some thanks. He's been awesome. They're rocking and rolling. That's been a problem for a long time, but so we have a really, really talented team of developers. I'm really fortunate to be working with so many brilliant people. But I mean, I shouldn't say so many, it's four, but to me, it's a lot. But anyway, so we want this developer ecosystem to become decentralized and flourish. So in order for that to happen, you're going to need to have multiple entities that are all independent of one another that can self-manage. So you need marketing and you need development, and that's essentially what an embassy is you have your marketing and your development. Ambassadors are marketing, developers are development, and then you have this judicial branch, which is kind of like the liaison. They handle all the icky stuff like finances and accounting and taxes and all that administrative crap, but they don't have any authority over the other arms. At 2 of 3 is all that's required to ratify budgets. So really, they don't have any say in budgets as long as developers and ambassadors agree. When they don't, that's when they step in to help resolve that. I'll get into all of the details of the internal embassy in the Constitution when I come into Telegram to ratify it. But to understand the core level voting protocol, that's, as I was stating, you have the poker chips. So when an embassy proposal comes, you take some of your poker chips and you allocate it on that embassy. Let's say you want to take 20% and you want to put it on the U.S. embassy. And then you see this new embassy in Australia. Maybe you know somebody there that's doing the work and you like them. You maybe put 50% of your stake there. And then 30%, let's say you put that in a European embassy. And that's your faith. You're staking your faith on these entities in order to provide development and marketing and all of those things. Now, over the course of the voting protocols, as more of these contracts, these proposals come and spring up, then that value will be averaged based off of your coin-weighted stakes. So, let's say the U.S., they got, 20%, and then 50% to the Australian. So the 20%, and let's say someone else did 70% to the U.S., and so on and so forth. That would be averaged out to be a certain percentage value, and that's going to determine the percentage value or income to that embassy. So that stake can be removed at any time as well, and that's really important. So the deposits to that embassy will be most likely a weekly frequency. These numbers are to be decided because we're in the architectural stages. We're not necessarily in the fine tuning of the numbers yet, but a week is what I've generally kind of come to feel is a good time limit, which means let's say if there's an embassy that somebody in the community disagrees with and they're not being heard, then just remove your stake. And then now that embassy, that next week, they're going to get less income, which means there's going to be less budget for all the people. And it's going to create a direct feedback loop between the community and the people that are essentially providing the services to the community, right? They're helping in the promotion and the marketing and the development. So this creates a really positive feedback loop and allows you at any time to readjust your stake in order to reallocate where you feel confident. And that could very well be in yourself. You can take some of your stake and vote for a proposal that you yourself believe in. And what happens then with the peer-to-peer messaging and the trust is that gains you entry into a new chat group. When that's all complete, you'll essentially, when you stake on that embassy, then you'll gain access to that chat group, which then also creates a positive feedback loop for the embassy because they know the people that are in there are people that have a voted stake. And, if they do not please the people that they essentially have been staked on, then they lose their income, and that's a direct accountability to them. So over time, bad embassies will essentially just fizzle out. They will lose their income, and people will forget about them, and then new ones will take place. And then each of these will essentially be self-governed through that constitution. So that's what to look forward to in our Tritium++ rollout, right? We got our 3 phases Tritium++ right now, which is essentially our first hard fork mobile wallet, desktop wallet, and then our final phase Tritium++, which includes pretty much all the bells and whistles, the rest of all the core fundamental features. So by the end of Tritium++, we're going to have a full-fledged smart contract platform. Now it'll be, and DAO, and so it'll be single dimensional. So it will still be running on a blockchain, but it's fast. That's why I developed a lower level database. All of those things, it'll still be quite fast. And the reason we're starting single dimensional is we want to get our ducks in a row. We don't want to add complexity too fast. It's called combinatorial explosion, which means if you add too much complexity too fast, that complexity multiplies, and it exponentially multiplies until you get this crazy combinations of complexities that essentially cause the program to implode. Ethereum is constantly fighting combinatorial explosion, right? Because they started with a pretty high complexity, and then they didn't really look at the architecture, I guess, long enough, and so now they're playing catch up to try to just catch up to be able to maintain that, right? We're proactive. We've designed it to work from the gate. So then obviously, once the Tritium++ phases are done, that leads us into a mean, which then adds our sharding layers. So that will start off as a voluntary sharding system, which means you'll still be able to process over the Tritium chain if that's what you want, or you can opt in to be processing in a shard. And so that allows, small microtransactions to start becoming shard dependent, and allows people to slowly move into that as they see fit. And that really gives us, as I said, our consistent phased rollout for the three-dimensional chain, and then finally to Obsidian, which ties that all together into a three-dimensional block. Over the coming time, I will be providing more and more demonstrations and architectural documents on the multidimensional chaining model. So more of you that are geeky, want to learn about it, you can learn about it. So development has been moving pretty steady, pretty good. It's been a breath of fresh air to be out of framework development, future-minded, grueling code now to save time later, to actually being able to build bells and whistles off of it. So being able to materialize these things so quickly is a testament to that, because the framework is very concise, it's well built, it's easy to add things. I don't have to copy and paste code. I have all of the functions that I need to access and modulate and change any of the data types. I have my templates, and now I have this wonderful Kyber handshake model with fully authenticated communication, and then the reverse tunneling router, which can be used for many more things on top of that. I think I forgot to mention the VPN, because that was a big community request. The VPN, consider that kind of sitting on the side of all of these updates. It can be done with Lisp, but I'm going to need to support OpenVPN protocol, because I don't want to have everyone need to re-download a new client. I want just OpenVPN clients to work, and potentially other clients too, of the native, I think it's PPOE, or P2PKS, or something of those. They're like native built into iPhones and stuff. The VPN, think of that as kind of being an ongoing thing. That's going to constantly be being developed in the side. And I forgot to mention about the file system. That you can expect that in the later Tritium++ phases. That will be the file system we complete by the full rollout of Tritium++. And that will include the capabilities to host, store, manage, sort, and search files, right? And publish files. So that creates a foundation for decentralized search, right? And that allows you to store additional data. Well, you only have to store the meta on the chain, make sure that the files aren't tampered with, so on and so forth. So let me recap. This week, we have completed a lot of the post-quantum encryption. I have got on the relay server up and mostly completed. I have a couple more protocol commands to complete, and that's going to be running. That provides the peer-to-peer messenger API, that provides a crypto API, and that provides a remote login. Kendall is finishing his new live builds for the public live tests. I should have those links. I will post them in response to the recording for this tweet, so that you'll know exactly where to get that if you're listening to this. Make sure to share this recording with other people if you want to show them what Nexus is about, what we're doing. Now, then phase 1 of the rollout. That's phase 0 is the testing, new desktop wallet, new mobile wallets. Phase 1, release the new desktop wallet with all of the new UI features, the new 5.1 core, all of those good things. Then phase 2 rollout is going to be a hard fork. That's going to be another desktop wallet, but a mandatory upgrade. And that's going to have a time lock activation for the difficulty adjustment 2 or 3, maybe 4 weeks out from the release date. And then the mobile wallet will be added to the App Store, and that's going to be the phase 3 when it's published into the App Store, which will make it fully available for everyone to be able to download without needing test flight or any of the other difficult setups. So I won't recap on all of the post Treating Plus Plus or this set. You can listen back if you want to hear the details again. But there's lots of new feature build out. Things are progressing very smoothly. I've been pleased. It's been great to be working with the team. We are currently essentially, there's someone that's starting to help with basic unit tests. He's kind of in training right now. He'll probably introduce to the community at some point. He's been really awesome. We've been doing some training calls and stuff. So there's new talent coming in and getting involved. And the remote login functionality will be in a UI component in the mobile wallet. I felt like we all felt that was really important to include if we're releasing remote login, to have the capability to access it through your mobile wallet. So that's one reason why the mobile wallet is the last phase. 2, it's the most complex. There's a lot of idiosyncrasies building a node on a mobile wallet and all of the likes. So that's about it for this development update. As usual, thank you everybody for the support. Thank you for the patience. I know it's been very difficult for some of you. It's been difficult for me too. You should try being there building it. I mean, it's fun to play with code, but having to build code that you can't play with, it's not as fun. So I've been having a lot of fun lately. I hope you guys continue to be having fun. So after this rollout, I'm going to be focusing too on the Constitution, depending. That should be materializing for them definitely by phase 3. Potentially in the gaps between the two. The VPN, I'm still assessing exactly how I want to do it, doing a little bit of research on, capturing the network packets off the socket interface or the network interface and stuff like that. So, and that obviously needing to have a paid model. So that one's just consider that one somewhat decoupled from any official update, and it'll find its way into one of them at some point. And then the file system, as I said, is going to come after these 3 phases. That'll come in the following hard forks, which will have a lot of really cool goodies. Essentially, I want it to be auto-configuring, easy to launch your own web service, and then eventually some really cool stuff with DNS. I think I've spoken about it before, but I'll save that for the next discussion. So, as always, I appreciate everybody, and I will see you next time.